Hello friends, in this video we will solve gate problems and it is related to retaining wall and earth pressure. So there is 2024 set 1 problem. The problem is like this: find the inclinations of the failure planes with respect to major principal planes for the Rankine's active and passive earth pressure. So, in Rankine's earth pressure theories that you have a retaining wall, and this retaining wall, the back of the retaining wall is going to be a smoother one. So this will be smooth. That means there is no friction between the backfill and the back of the retaining wall, and this angle is going to be 90 degree. This is vertical. So you have to find out the inclinations of the failure planes. The failure plane in active state or in active condition will make an angle of 45 plus 5 by 2 with the horizontal. So, in active state, you will have to find out the inclination of the failure plane with respect to major principal planes. Now, in active state, if you take a soil element, the vertical pressure is going to be more compared to the horizontal pressure. That's why the soil moves in the forward direction or away from the backfill. So what is the condition here? That the major principal plane is going to be horizontal, because sigma, since the vertical pressure is greater than the horizontal pressure, therefore sigma b is the major principal stress, and this plane, horizontal plane, will be the major principal plane. So this is the major principal plane in active condition. So if it is the major principal plane with respect to the major principal plane, what is the inclination of the failure plane? The failure plane with the horizontal, this is horizontal, is 45 plus 5 by 2. So therefore, inclination with respect to major principal plane in active state is going to be 45 plus 5 by 2. Now, let's go for passive condition. In the passive condition, there is the retaining wall. This wall, it's moving towards the backfill. There is the top of the backfill, and the failure plane in passive state is going to be like this. As a result, the vertical pressure is going to be less than horizontal pressure. So horizontal pressure is always more, and therefore this moves up the failure plane. So here this is your failure plane. Here this is your failure plane. So if you see the major principal plane here, which is the major one, major principal stress is going to be this one, and this is going to act on the vertical plane. So vertical plane is the major principal plane in passive state. All right. So with the vertical, here with the horizontal, in passive condition, this angle you know is 45 minus 5/2. So as per Rankines, with the vertical smooth wall, this angle will be 45 plus 5/2. So this is the vertical major principal plane. Therefore, inclination with respect to major principal plane in passive condition equal to 45 plus 5/2. So both in active and passive condition, the inclination, what should be the answer? It is 45 plus 5/2 for both active and passive state. So with this diagram, you can explain it like this. Friends, I think it's an intelligent way of attempting this problem. The next problem on earth pressure and retaining wall is of 2000 to 3 set 2. You have to draw the force polygon for the given failure wedge in passive state. So you have a failure wedge which is in passive state. So this is the wall which has been given in the question. This is the retaining wall. This angle is 90 degree, and this is the wedge. So this is the failure wedge. This failure wedge, and this is the failure plane. So or slip plane, this is the failure wedge. Failure wedge, and the conditions are given over here. This is in passive state. And the first is, it is C5 soil. So this soil is C5 soil. The second is, passive earth pressure is given to you as P. Now here, draw a normal. And the passive earth pressure here with the normal will make an angle of is P, will make with the normal an angle delta. You know it. Then reaction on failure plane. This is your failure plane. The reaction here also draw a normal, and the reaction will be at an angle phi. This is the reaction R, and this angle will be angle phi. So you know the direction of R, and the cohesive force acting along failure plane is known to you. So the wall will have a tendency to move towards the backfill in passive state. Therefore, the force of cohesion or the cohesive force will be acting. So this is the cohesive force which is acting opposite to the movement of the wedge. So on the failure plane, this is the cohesive force C. So C is the, here you can see C is the cohesive force. So cohesive force you have seen this reaction. So all the forces are known to you, and let's say the weight of the wedge W in passive condition. So now if you draw a force polygon, let's draw the weight. Weight, you know it. Both you know the magnitude and direction. Then next comes this cohesion acting along the this. So parallel to this, you can draw a line, and that becomes the force, cohesive force. Then it is the reaction force which is shown. So parallel to this, you can draw the reaction force. So you know this, and you know the origin of the W, and you know what is PA, how PA is acting. So you can draw PA parallel to this, that is the passive force P, and this is parallel to reaction. So this is the force polygon. This should be actually parallel to this, like this you should draw. So parallel to this. So R, W, C, R, and P. So this question was to draw the force polygon, and we are able to do it in Coulomb's failure wedge or wedge theory. You have learned how to draw the force polygon. So it is quite simple. You can draw the force polygon. So in the examination, you see in the GATE examination, the questions are not very tough. It's going to be of very simple nature. The next problem we will be taking of 2022 set 1 is another GATE problem. Here, as per Rankine's theory, the problem is like this. Rankine's theory of earth pressure, the inclination of failure planes the inclination of failure plane is 45 plus 5 by 2 with respect to direction of minor principal stress. Minor principal stress. Find the state of the backfill. So, as per Rankine's theory of earth pressure, the inclination of the failure planes is given over here with respect to the direction of minor principal stress. Minor principal stress is going to be sigma 3. Major is sigma 1, minor is this. Find the state of the backfill. So, solution, quite simple problem. Let's say this is the wall and the backfill, and the failure plane in active condition is inclined with the horizontal at an angle of 45 plus 5 by 2. This is in active condition. So, if I take any soil element, sigma 1 equal to sigma v and sigma 3, that is the minor principal stress, equal to sigma h. Now, here it is minor principal stress. So, with the minor principal stress, it is acting on the vertical plane. Here, the minor principal stress equal to sigma 3 equal to sigma h. So, as per Rankine's theory of earth pressure, the inclination of the failure planes is 45 plus 5 by 2 with respect to the direction of minor principal stress. So, the minor principal stress direction is horizontal. Direction of sigma h is horizontal. So, with the horizontal, the failure plane is making an angle of 45 plus 5 by 2. So, with minor principal stress, this failure plane is going to make an angle of 45 plus 5 by 2. Therefore, inclination of failure plane with respect to direction of sigma 3 is 45 plus 5 by 2. Okay. Now, if it is a passive state, then what is going to happen? This is the wall. Now, here this is going to be major in passive state. And the downward pressure on the soil element is going to be minor. So with the minor, now this angle is going to be 45 minus 5 by 2. Now sigma 3 here, the minor principal stress is vertical. So with the vertical, what is this angle? The failure plane, therefore, makes an angle of 45 plus 5 by 2 with respect to minor direction of minor principal plane, principal stress. So with respect to sigma 3. So sigma 3 is going to be the minor principal stress is going to be this. So here sigma 3 is vertical, is minor principal stress in passive condition. So with vertical, this angle is 45 plus 5 by 2. So we see that the inclination of failure plane with respect to sigma 3 in both active as well as in passive condition comes out to be 45 plus 5 by 2. So the inclination of with respect to the direction of minor, find the state of the backfill. It is both active and passive state. This is the answer. And we have justified it by explaining completely. So these tips will go a long way in shaping your knowledge. And the next problem, which is again of 2022 on retaining wall and earth pressure, we'll go to the next problem. Friends, the next problem looks like this. We have the effective vertical and horizontal stresses. So sigma V prime and sigma H prime are effective vertical and horizontal stresses respectively. And you have to find the conditions to be satisfied. Find the conditions to be satisfied for a soil element to reach the failure state state under Rankine's passive earth pressure failure under Rankine's passive earth pressure condition. So this is the problem. You have to find the solution of this. Sigma V prime and sigma H prime are given you as the effective vertical and horizontal stresses, and it is in Rankines. So in Rankines you have a wall which is going to be, the back of this wall will be smoother and vertical. So if I take the active state, you have to find here to reach the failure state under Rankine's passive earth pressure condition. So in passive state, the failure plane will be inclined -45 5/2. That means with the vertical 45 plus 5/2. So if I take any soil element, this is going to be sigma 1 and this is going to be minor, because it has a tendency to move up the failure plane, and this is the failure plane. So find the conditions to be satisfied for a soil element to reach the failure state under Rankine's passive condition. In passive condition, which is more, the horizontal pressure is more and vertical pressure. So you know, in passive, the coefficient of passive earth pressure, Kp, is always greater than 1. And what is Kp? Coefficient of passive earth pressure is always greater than 1. And what is coefficient of passive earth pressure? It is the ratio of sigma H prime upon sigma V prime, should be greater than 1. Therefore, sigma H prime should be greater than sigma V prime, or the effective vertical pressure should be less than equal to sigma H prime. So this is the condition to be satisfied. So here, what conditions to be satisfied for a soil element? For a soil element, the condition to be satisfied is this, that the horizontal pressure or the horizontal effective horizontal stress will be greater than vertical, or vertical will be less than horizontal stress. So this is in passive state. So conceptually, we have addressed this problem of 2022, and the next problem we will take it. So friends, now the next problem is going to be of 2020. So 2020, gate problem, set 1. Now here, for a retaining wall of height 5 meter, which has a backfill soil, so see the figure first. See the figure. The question is like this. From figure it is amply clear. There is the wall, 90 degree, and here this wall has a C5 soil as backfill. So gamma is given to you as 18 kilonewton per cubic meter, and the value of C prime is 12 kilopascal, and the value of phi prime is 30 degree. And you need to find out the lateral active thrust. Find the lateral active thrust, that is PA, isn't it? That is PA on the wall in kilonewton per meter length of the retaining wall. So this is the question, and the height of the wall h is given in the problem as 5 meter. So how will you solve this problem, because it is C5 soil? So the soil is C5. Therefore, if I take any soil element, the soil element at any depth, say Z, and is sigma V, is sigma H. Now, vertical is always more. So this is major principal stress and this is minor principal stress. So what is the relation between sigma 1 and sigma 3? You know the relation. Sigma 1 equal to sigma 3 tan square alpha. Is it in active state? Plus 2c tan alpha. This is the relation between sigma 1 and sigma 3. Therefore, sigma V equal to sigma H tan square alpha plus 2c tan alpha. Therefore, sigma H equal to sigma V cot square alpha minus 2c cot alpha. This cot square alpha is called coefficient of active earth pressure, and therefore, and sigma H is called the active earth pressure. The horizontal pressure is called the active earth pressure. So PA is the active earth pressure, A for active, P for pressure, and sigma V will be due to overburden, it will be gamma Z. So gamma is given to you, and at any depth Z, it will be vertical pressure will be gamma Z into K minus 2C under root K. So at Z equal to 0, that is at the top of the backfill or top of the wall, here in this equation 1, if you substitute Z equal to 0, the active pressure is going to be negative. So the pressure is going to be negative and this can be calculated. This will be C prime So minus 2 into C prime is given. And for phi equal to 30 degree, the value of K will be 1 by 3, that is 0.33, we can take it. So into under root 0.33. Now calculator will be required. So take the calculator and that is 13.78. So PA equal to minus 13.78 kilopascal at the top. So the pressure is, if I take a reference line, this is the reference line I'm going to take. So here it is going to be minus 13.78 kilopascal at the top. And then if you look to this equation A, as Z increases, as you go down, there will be a depth where the first term and second term becomes equal, resulting into active earth pressure as 0. So and that is called the depth of tension crack, Z equal to Z0. So at Z0, PA will become 0. The first term and second term becomes equal. Therefore, if I substitute in equation 1, Z equal to Z0, Z0 will be 2C upon gamma under root K. So here PA is going to be 0. From negative, it has become 0. So this is Z0. So please calculate it in meter. This is the equation. So this becomes 2 into C prime divided by this the value of Z0, you can calculate it. Let us calculate. .32 meter. So this is 2.32 and total it is 5 meter. So remaining depth you can calculate it, minus 5. 2.67 meter or 678, so 68. So remaining depth is going to be, this is Z0 and this one is 2.68 and this is Z0, 2.32. So total it becomes 5 meter. So now the pressure at H, this is the at H, that is at the bottom, From equation 1, it will be gamma H K minus 2C prime under root K. So we can calculate what is the pressure here. So it will be, we know all the values, 18 into H is 5 meter into 0.33 15.91. So this pressure is 15.91 kilopascal. So now, because of the negative pressure, you will find there will be a vertical crack like this. A C5 soil, you will find there is the vertical crack. So no pressure on the wall because there is a detachment in the backfill. So here it is 0, here it is 15.91. So for finding out PA, which is here, find out PA, the active thrust, will be area of this pressure distribution diagram. Therefore, it is very simple. Therefore, the active earth pressure will be half into base, that is 15.91, into the height is 2.68 kilonewton per meter length of the wall. So I will calculate it, multiplied by 2.68. It is 21.32 kilonewton per meter length. This is 21 point. This is the answer. So we have drawn the pressure distribution diagram and solved this problem. This is a very important problem. So you can subscribe my videos for such problems, and I will give you few tips so that in the examination you are in a position to solve all your problems without any difficulty. I hope you have understood it. If you have any queries, please do post your questions. I will try my level best to answer it. And in the next video, I will try to do rest of the problems on earth pressure and related to retaining wall. So thank you, friends.